Um, no,
It's basically a running total. I used to have this a bit better. Let me... maybe this one on the left. That's kind of a special one. Oh, are they all like that? Oh, they're all like that. So the first one on the left, so the one up here is like 10 to 20, 20 to 30, 30 to 40. This one here is 10 to 20 is 4. How many are between 10 and 30?
10. Wait, so it would have been 5.
So like from 10 seconds to 30 seconds. How many in total?
Oh, so how many seconds in between?
No, like how many people or whatever it was.
Huh? I don't understand.
So let's say this was people who ran a race or something, obstacle course, and this is how long it took them to finish. So 4 people did it between 10 and 20 seconds, 7 people between 20 and 30, and so on. So how many people finished between 10 and 30 seconds?
So 11.
Yeah. How many 10 to 40?
Um, 10 to 40, 24.
Yeah. 10 to 50?
10 to 50. That would be 36.
Yeah. And 10 to 60?
40.
Well done. Okay, how about this one over here?
Oh, which one?
Question on the right.
Okay.
It's just one big question.
So 0 to 10 is 5. 0 to 30 is 16. 0 to 50, that is 39. 0 to 80 is 52. And 0 to 160.
Well done. So it's just a running total. These are all exam questions. There's a million of them. None are any more difficult. I mean, some of the numbers are a bit bigger, but... okay. This is a cumulative frequency diagram. Have you done these before? Had to find the median?
No.
So...
I don't think I've done it before. I think we did it, but not with the median.
Okay. You have to draw a cumulative frequency diagram. So it's like 0 to 20, 0 to 30, 0 to 40. And here's the cumulative frequency. Any idea how you go about drawing a cumulative frequency diagram from this data?
So
you have to say like what are the coordinates of the points.
okay. So would the first one be 20, 25?
Yep.
and then 30, 70,
Yeah.
and then 40, 138,
Yeah. How about the last one?
80, and 200.
Well done. And so for a frequency polygon, we were doing like the midpoint as an estimate. For cumulative frequency, you use the endpoint, and that's because we definitely know that like 50 or fewer, there was 175 people who are 50 years old or younger. That's 186. Okay. What do we do with this, with these points?
You put them on the graph.
Yeah. So you go across the 20, up to 25, do your graph. 30, 70. So you put all these on, and in the end, you'll get a shape. What's the last one? 80, 200. Let's see. I don't know. So in the end, you'll probably get a shape something like that. And that's a cumulative frequency curve. What does the curve go up to?
The curve goes up to 200 and
Yes. And
80.
that's the total frequency. So 200 was total frequency. Oh, hang on. How would you find the median if you have the curve? Where's it going? Yeah. How would you find the median using this?
The median. The median of the line.
Yep. So this was 200 workers at a factory.
So 200 workers. So you have to find the mean. So it's always, you need to arrange it in order. And then the middle one.
That's true. That would be from the table. That would be the long way. So which worker would be the median one?
Um, 40. The 40.
So it'd be the 100th worker, and they'd be between 30 and 40. Because yep, you can also use the line worker 100. Now I just used an estimate, so I don't know how good this is, and I'm getting it's about 30. It might be a bit more than that because my line, I just estimated it because I didn't want to spend time putting in all those X marks. Well, maybe I should. It'd take too long. And that's how you find the median. Okay, median. Or hang on, I'll find it out. Yeah. How about the median for this one?
So the median would be, because that's 60. So it would be 30.
So it'll be the 30th person. And so what was their test score?
The test score was 40.
Well done. And that's 40. And so yeah, when they draw the line for you, you have to get it exactly right. So use your ruler when you do these on paper. If you draw the line yourself, they give you a bit more leeway. Any idea about this one?
The median it is 30, and it is 120, 128 online.
Yeah, so it's not easy for me. Yeah, got it. 128. Great. How about this one?
Okay, so median 10. Median is 10.
Yep.
And then the mark for it would be around 40, 45 or 46.
Let's just say 45. What was it actually? Okay, it's 46, I think. 45 to 46, yeah. And how'd you know it was 10?
Because the top mark was 20.
It wasn't quite. The axis went up to 20. The top mark here was actually 19. The y is going up in 2's. The x is going up in 2's as well. It's because 19 plus 1 over 2 gives you the 10th person. So just watch out for that. This one is, although like the paper goes up to 20. That one doesn't really. So how about this one? What does this one go up to?
So this one goes up to, it's a bit above 80. So I'll say it goes up to like 83, 84.
So it would go up to 84, except what number is here?
70.
And so what does one square represent?
1, 2.
Yep. And so 4 squares above 80. It isn't 84. What is it?
88.
Well done. And so median person? Or median plant?
So the median would be 44.
Yeah. And so how many squares above 40 is that?
2.
Well done. And so what does that look like?
It looks like 80, 83.
Well done. 83 centimeters. The y is going up in 2's, but the x is going across in 1's. That's nothing wrong with that. 83. So this one, yeah, it wasn't 84, it was 88. You half it, go across, hit the line, go down. And you could also do like the median person would be technically halfway between 44 and 45, so it'd be like 45th person. The thing is, 0.5 would be not half a square, it would be a quarter of a square. And so because it's so close, we just use 44. So this one, don't bother. 44 is fine. Because with a graph, we're just doing it by eye anyway. And this one, that's going to be fine. These are going to be fine. How about this one?
Okay, so the middle is 70.
Mm-hmm.
And 70 goes down to 44.
That's a good point, yeah. It's about 44. So it's 43. Anything between 42 and 44. I think you're good for these. Yeah. Okay. How could you do this one?
You have to do A and B.
Yep.
Okay, so for A, actually the middle is the same for both of them, so it's 50.
Yeah.
And A would be 100. 156.
I think so.
And B would be 163.
Mm-hmm. And so use that to compare the heights of two groups of children.
So group B is taller than group A.
Yeah, so on average, the children in group B are taller. The children in group B are taller. Do you remember the second thing that you used to compare two groups?
The second thing. No.
The spread. And in this case, so to measure the spread, you could use the range. Any idea what the range is for group A or group B?
The range is from 100 to 0.
That's the number of kids. What do the heights? What's the range of their heights?
The range of the height is 56 to 156.
Tallest boy, shortest boy.
The tallest boy is 170. Shortest boy is 145.
Mm-hmm.
So the range.
How do you get range?
Subtract.
Mm-hmm.
Your answer would be 25.
Yep. How about the range for group B?
Group B, so the smallest is 50. Shortest is 50 and tallest is 170.
Mm-hmm.
So the range is 20.
So on average, the children in group B are taller. What could you say about how their heights are spread out?
How the height is spread out. What do you mean by that?
Whose heights are more spread out?
The group A.
Yeah. The heights of the kids in group A are more spread out. There you go. And that's how you compare two data sets. Who is taller on average and whose heights are more spread out. So group B, they're taller on average and they're more consistently tall. Their heights are less spread out, so they're closer to that higher average. Well done. Okay, this one. We have to get the interquartile range. Any idea how to go about that?
Interquartile. I do not know how you do that.
So the median, so it's 60 apples. So the median would be that one. The lower quartile is like the median of the bottom half. The upper quartile is like the median of the top half.
Okay. So, what's interquartile?
Which apple is the lower quartile one? If the median apple is 30?
Pardon?
So for this one, it would be like a half would be the median. A quarter of the like the quarterth apple is the lower quartile. So that's like the middle apple of the bottom half. And then at the 3/4 mark is the upper quartile. And so what is 1/4 of 60?
1/4 of 60 is 15.
Yeah, so that's like halfway at the bottom half. Okay. And then upper quartile, 3/4 of 60.
3/4. That is 121.
Okay, so the lower quartile is 121. Looks like the median's about 128 or something. What is 3/4 of 60?
3/4 of 60. That is.
It would be 1/4 times 3.
So that would be 45.
Yeah. So that's 1, 2, 3, 4, 5. Go across. Hit the line. Go down. What does that look like?
132.
32. And so the range is the max minus the min. The interquartile range is the upper quartile take away lower quartile. And so what is the interquartile range for this question?
So interquartile. So is it the weight? You take away the weight, not the number.
Yep.
Okay. So different.
So for this one, it'd be 132 take away 121.
Okay, so that would be. So 11.
So I think it's 11, but I'm just using the computer. So, hey, 11. It is 11. It's exactly 11. Great. So if they want, when they asked for the range was easy enough. We would just go to the end. We'd say the heaviest apple was 150 grams. The lightest apple was 110. And so the range is the min minus the max. It's 150, take away 110. And so it is 40. The interquartile range is the spread of the middle half. So from the 1/4 mark to the 3/4 mark. The median apple was the 30th one. The lower quartile apple was the 15th one. The weight of the 15th. Upper quartile was the weight of the 45th. And so you just go the weight of the 45th apple, take away the weight of the 15th. So like upper quartile minus lower quartile. Any questions about that?
No.
Okay. We'll come back to that. So it's, that's okay. I come back. I'll go with one. Yes, how about this one? And we did the median, so let's just do interquartile range.
So interquartile range. So you have to half it.
So the median was the 10th one. Yeah.
And then so half of it is, where's the number? So then you need to find 1/4.
Yeah. So half is 10. It went up to 20 in total.
Yes. So you just need to. So we're just doing the interquartile range.
Yep. And so the lower quartile is like the middle, like half of the bottom half.
Yeah, and there's 5.
Yep. Okay.
And then that one would be 30.
I think so. Might not be exact.
And then you have to find 3/4 of it. So that would be 15.
Yeah.
And that goes to about 53 or 55. 55.
Let's see. Well, 50 is halfway. I think these are going up in twos. So 8, 6, 4. Yeah, 54. I don't know. Okay, so the upper quartile is 54. The lower quartile is 30. Interquartile range?
Interquartile range 24.
Well done. Interquartile range is 24. And what did we say the median was for this one? I don't remember. Looks like it's about 45 or something. Okay, you have to compare.
Okay. Compare the interquartile range of the marks of Mr. Wilson's class with the interquartile range of Mr. Wait, so we have to find interquartile for Mr. Wilson?
Yep.
Okay.
As well as the median.
So, how would you find interquartile if it's if the graph looks like that?
Did we do box plots? I think we did it ages ago, did we? Let's see. Yeah, we did it in the summer. Any idea which one is the median in the box plot?
The median is that 50.
So I think it's 50. So the median is 50 marks. This one here is the upper quartile, and then this one here is the lower quartile.
Okay. Oh, okay. I think I remember it now. So, lower quartile. So lower quartile is like 30, around 30, and then upper quartile is 64, and take them away, and that is 36 as 36 as interquartile.
Mm-hmm.
And then compared, you have to compare it.
Mm-hmm.
So you have to subtract again.
No, just compare. Which class did better?
Oh, okay. So Mr. Wilson's class did better.
Yeah. So on average, Mr. Wilson's class scored higher. What about how spread out the marks were? How spread out the results were?
Mr. Wilson's class results was a spread down.
Did say better. So the interquartile range up here was 24. Yeah, but his results were more spread out. So he would have had lots of students, like, bit inconsistent, you know. Well done. So if you have to compare a cumulative frequency diagram to a box plot, two things, average and spread. The median is the simplest. Just go across from the middle, hit the line, go down. For this one, median was 50. So you can see Mr. Wilson's class did about 5 percentage point or 5 marks better on average. And then do interquartile range, and see which was more spread out. Any questions there?
No.
Tricky. Okay, let's find interquartile range for this one. And I remember we did the median for this one, and it was 44.
Oh, yeah. Yeah, I remember that. So, interquartile. So, first you find the quarter, and the quarter is 22.
Yep. How many squares above 20 is that?
One.
Well done.
So then, that would be 78.
Yeah. These are going up in ones, and these are going up in twos. Okay.
And then you need to find 3/4. So 22 times by 3 is 66.
Yep.
That's 3 above 60.
Let me see. It looks like it's that one right there. Does that look like?
Yeah, and that is 87.
87. Okay. So interquartile range?
So interquartile is 9.
I think it is 9. And it is 9. Well done. That other thing, I might do in a minute. So draw a cumulative frequency thing. Draw a cumulative frequency. I was going to use their one. Let's try this one.
Okay. So we have to find the cumulative frequency.
So this is a cumulative frequency diagram.
So median.
Hang on. How many scored 43 or more?
How many scored 43 or more? People. How many more? One estimate a number for the people who passed the test. So everything above 3.
So 1, 2, 3. So this is 60 people took a driving test.
Yeah.
Oh, hang on. I did it wrong. They got a score.
The test score is at the bottom.
Yeah, they got a score of 43. So that's 1, 2, 3. It's like that. So how many scored more than 43?
So that is like 37-ish.
Mm-hmm.
So then that means that 23
Well done.
more.
I don't have the answer, but yeah, that's it. Great. Well done. So now I can go back. This one. How about question C?
Question C. Find an estimate for the number of Holyoke bombs taller than 90 centimeters. So 90 at the bottom. Go up. So that is around like 17. This is going up in twos, right? So 78.
Well done.
78 and taller than 90.
How many people are taller than 90 centimeters?
None. 0.
Why'd you say that?
Oh no. Sorry, I got it wrong. I thought it was for the cumulative frequency, but it's not. So how many people? It goes up to 88. So 10 more people.
Yeah, or I should have said plants.
10 plants.
Yep. There we go. 10 plants. 88 minus 78. Well done. So for these, a lot of the time you have to draw it yourself. That's long, man. You just have to. But then they say how many were above a certain thing, how many were below a certain thing. I just don't want to spend a lot of time. Yeah, I just don't want to spend lots of time drawing these. There's that one. Okay. This one, yep. this is a histogram. I don't know why that's there. Hang on. Do that. Okay, how about this?
Okay, estimate for the number of cars passing this speed come at greater speed than 72 miles. So 72 is 72, and that is about 380.
What's this number here?
Oh, it can't be that. 340.
Yep.
So 60 cars.
60 looks like. 50 to 60. Great. And 340. Yeah, great. More than 30 minutes. You're good. You're good for those ones. Let's see this one. This is just draw the graph. So a lot of these require you to have the graph already, and it just takes a long time to draw it. Hey. Alright, so this is worth more marks. We'll see. Okay, how about this one?
Cumulative information about the time 80 swimmers. A swimmer has to swim 50 meters in 60 seconds. First and 25% us is the team captain, right? So you have to do 25% of 80. Is this a calculator question?
No.
Okay. So 25%.
To find 25%, just half it twice.
So that would be 20.
Yep. Okay.
So 20 swimmers, more than 20 swimmers have qualified.
So how do we check if he's right?
Swimmer has to swim 50 meters in 60 seconds. So you go on 60 seconds.
Mm-hmm.
And then you go on to the line, and that goes to 30. And then, not 30.
There.
So about 29, 20.
Okay.
20. And then more than 50. So more than 20 swimmers.
So which swimmers took less than 60 seconds?
Which swimmers 27 swimmers took less than 60.
Yeah. So these swimmers in here, they took like between 20 to 60. And so, is he right?
Yeah.
Yeah, he's right. Yes, 28 is more than 20. He said more than 25%, so that's more than 20 swimmers. Yeah, it was 28. Yeah, 28 is bigger than 20. Perfect. Well done. So sometimes you have to say how many are more than it. With these racing questions, the lower your time is, the better you are. And so it's how many was less than that. So just watch out for those. This one's similar. Let's try it.
Okay. Speed limit. Traffic police say that more than 20%. Okay. Comment on what the traffic police says. Say. So the traffic police. The speed limit. So first you have to do speed. So you do 130 and you go up to meet the line.
Mm-hmm.
And that is 53.
That's about that.
So 53. Come on, he said more than 20. So then
I think it's 54.
So then you do 20% of 60.
Yep. Non-calculator. What is 10%?
10%. That is 6.
And so 20%?
12.
Mm-hmm.
Okay. So it's 12. So more than 12 cars. And that goes up. I think he's wrong.
Yep. Because 6 is less than 12. Not true. Yep. Okay, so it was 8, not 6. But yep, got it. Great. You were right, actually. This one you had to find the percentage yourself. Estimated mean. We did it. Okay. Let's try this. So I've done part A. Estimate the median, 43. Oh no, we did it earlier. Revise more than 30 minutes. That was 90. Okay. We did compare the distribution. How would you compare the distribution?
So compare the distribution. So you have to find out the you have to find the interquartile.
Mm-hmm.
Yeah, so you find the interquartile for both of them.
Yep.
And then you take them away. I mean, you find the you see which one is bigger.
What's the interquartile range for the box plot?
For the box plot. So with the so is the 2 lines of the box the outer and
Yep.
inner quartile?
Lower quartile, upper quartile?
Yeah, so lower quartile is 40,
Mm-hmm.
upper quartile is 70,
Mm-hmm.
And so the interquartile is 30.
Yeah. What's the median?
Median 50.
And so, compare the amount of time they spent. Well, okay, so how would you find the interquartile range for the diagram?
For the diagram, you find the median, which is 70. And then you get a quarter of that, which is 35. And that is 20.
22 maybe. It's kind of difficult for me to. Maybe it is 20.
Yeah, it's 21. And then you times it by 3.
Mm-hmm.
So you do 35 times by 3. And that is 105. So the next one will be 105. And that is 55.
It looks like 56, but I might be slightly off.
Okay. And then you take away, and you're left with 34.
Yeah. So the interquartile range is 34, and the median was 43. Okay, compare the two. This was the girls for this one, and this was the boys. And it's time they spent revising for an exam.
So it looks like the girls spent more time preparing.
Why is that?
Because they have the interquartile is 34.
That's not the
And
average. That's the spread.
oh, so it's average the median.
Yep.
Okay, so the boys did more.
Yep.
Provision. And then, but the girls' answers were more spread out.
Yeah. Times one more spread out. So, some of them did like much more than the average. Let's see. Yeah. I mean, you got it. You understood it. Find the median, find the interquartile range, and compare the two in context. So that's comparing cumulative frequency to box plot. Calculate mean. We did it last time. And yeah, so that is cumulative frequency. We did all of it. Yeah, so what would you give yourself a cumulative frequency?
I think I was good at it.
Yeah, and that's a real difficult one. Any topic in particular you want to do next time?
No.
So I'm making a lesson for all these weird graphs that come up. I think I'll do that. Any questions for me in general?
No.
All right. Well done, Carlos. You did great. I look forward to talking again next week.
Me too.
All right. Thank you. Take care. Goodbye.
Bye.